Hey everybody, Lars here. Shooting this video real quick on Friday night. At the end of the week, Unit 2 is coming to an end. Alright, tomorrow night, 8 o'clock, the quiz is going to be open, and the assignments are due at the end of the weekend, midnight, on Sunday night. Okay, you should already have that forum post up. I'm giving everything away. I'm doing the announcements before we even do the video. Video is going to be quick. I'm going to take 5 minutes. I'm going to tell you a story. Forgive my cold. Forgive the fact I'm going to be coughing through this whole thing. And then we're going to real quick take a look. If you've read the slides, we're going to take a look at number 6 as far as the Euler videos are concerned. And the way I get to Euler is that back 9 years ago when we first built the cave, we had a lot of Rutgers students coming in. And there were no Python classes. My class wasn't in existence. The one down in Camden was not in existence. And the students were starting to hear about Python and wanting to use it for data science and different applications. And they would come in and say, I'd like to learn Python. Well, what we did back then was we sent them to a website that you're going to be familiar with after you do the midterm. We're going to talk about that later too. Called Learn Python the Hard Way. It's kind of a joke. It wasn't the hard way. It was easy. And back in the day, it was 10 chapters. They were free, and you would go and you would move through these chapters online and do the basics of Python, kind of what you're doing now. And then at the end of the process, we would say, go to this website where there are a whole bunch of number problems and do the first 50 of these number problems. And if you can do the first 50 number problems, then you're probably okay with Python, and then you're ready to go and do that thing that you wanted to learn Python for in the first place. Everybody's learning Python for a reason. I want to do data science. I want to do this. I want to do that. Well, eventually you got to stop learning. You got to stop, put the book down. I don't mean to say stop learning. Bad way to put it. But you've got to stop with the toy programs and try to do that thing you're learning. Try to create that game. Try to create that program. Try to, put the books down and say, all right, now I'm going to do that. Because that's the only way we learn. We got to try things. It's like the whole Nike thing. Just do it. At some point, you got to get to just do it. Just get it done. At some point, you got to say, all right, rubber's got to hit the road and let's go. All right, so then that's what we would tell people. That's how we would have them do Python. And then later on, I get my class fired up and some other things happen. So we don't necessarily have to give those instructions anymore. But I always like, and I'm going to show it to you right here, to show people Project Euler. Because at the end of the day, Project Euler is 500. Is it 600 now maybe? Let's go take a look. 645 number theory problems, and they lend themselves to being solved with computer programming. There's a lot of discrete mathematics, there's a lot of puzzle stuff, and you'll see a bunch of this stuff. Now, one last thing I'm going to tell you before we're going to fire up Python and start coding is I shouldn't be doing what I'm doing right now, because part of Project Euler is not giving out the answers. Because if everybody knows the answers and we put the answers everywhere, then somebody who's brand new to this, they're not going to have their chance to figure everything out, right? So technically you're not supposed to be posting answers. That said, anybody who goes to Stack Overflow or anybody who goes to any of the forums or Reddit or anything like that knows that about the first 100 Project Euler solutions are out there. They're done in Java, they're done in C++, they're done in Python. So what I usually tell students is give it the old college try, if you will, and try to do it yourself for a while. If one really, really, really gets you, then go ahead and go to Stack Overflow and just Google, Project Euler number 53 Python and see what kind of solution you get. All right, but what we're going to do is we're going to take a look at number 6, which is the sum square difference. So what I would do is I would click on it, and I'm going to show you later. I set up an account. So we're actually, as a class, going to be able to go into this account and solve problems if you want. So it says the sum of the square of the first 10 natural numbers is 1 squared plus 2 squared plus all that is 385. Boom. The square of the sum, so take it and flip it, of the first 10 natural numbers is 1 plus 2 plus all that is 55. 55 squared, 3025. Boom. So the difference between the two, and you take their difference, is 2640. Okay? So we kind of have what we would call in education here a worked example. Oh, I need that coffee. Okay? So now we're not done. Euler says to us, all right, I just showed you a process for the first 10 natural numbers. What's the answer if we were to use the first 100 natural numbers? So you think, oh, okay, let's go up here. 1 squared, 50, blah, blah, blah. It's a lot to do by hand, right? And down here, this is probably easier. You'd have to add the first 1 through, 99 or 100, and then you'd have to square that. So it gets a little crazy, okay? But something like this is good for us because we know how to program in Python now. And the key, now that you've had Unit 2, is that you know iteration now. You know loops. And if you know a little bit about loops and you know a little bit about for loops, this really isn't that bad a process. So what we're going to do, first thing I'm going to do is this. Watch. I'm going to highlight the problem, okay? I'm going to copy it. Then what I'm going to do is I am going to run down here where I already created some code for us. Well, I didn't create some code. I got a file. And, I can't see anymore. Let me get my glasses. Let's give myself some comments, and I'll just say Lars, and I'll just say Euler 6. It's pronounced Euler, not Euler. I learned that the hard way. I seen Euler out loud in a math class once in college. Everybody laughed at me. And to this day, I still say Euler sometimes, so get ready. All right, what's the first thing I'm going to do? First thing I'm going to do is I'm going to say 1, 2, 3, and then I'm going to paste the problem. All right, but the format's a little crummy right now. So let's go make the format nice. There you go. So now I have the problem right there in my code. Let's save it for the first time right now. So I don't have to mess. I'll just call it Euler 6. I bet you it exists already. It does. Go ahead and replace it. I think I know we're going to be doing this again. All right, Euler 6.py. What's the first thing that I want to do? Well, when we're computer programmers and I'm looking at something like this, I don't really have one problem there. I have 3 problems. First thing I want to do is I want to solve the sum of squares. And the next thing I want to do is I want to solve the square of the sum. And then I want to find their difference. So that's 3 different problems. So let's tackle them one by one. So the first thing I'm going to want to do is find the sum of the squares. All right? So I think we know how to do that. I'm going to create a variable called SOS, or sum of squares. Forgive. And I'm going to set it equal to 0. And I'm going to tell you why I do that a little bit later. Then I'm going to say for I in range, and I'm going to start with 1 because I don't want to square 0. And then I'm going to go to 11, okay? Because I want to go to 10. And at the end of a range in Python, what is it? It's the first thing we don't want. It's exclusive. So I'm going to do that, and what am I going to do? I want to find the sum of the squares. So I'm going to say SOS is assigned, not equal to, remember equal to is 2. I want to say is assigned SOS plus SOS, no, not SOS, I squared, right? So every time I go through the loop, I'm going to add the square of I. So the first time I'm through, the square of 1 is 1, then the square of 2 is 4, and I'm going to keep adding these things up till I get to SOS. Then, when I have SOS, I will have added up all of the squares, and I'll have my number. So let's print it and check it out. So I'm going to print SOS. All right, so let's run this. Figure out if we're good. 385. We are good because we got a worked example up here and it's 385. Let me get rid of that. Okay? So we're in pretty good shape. We got the first one licked already. All right? So now I'm going to cheat a little. Watch me go. I'm going to grab all that code. I'm going to say Control C. I'm going to come down here, Control V. Only now we're going to do it backwards. I want the square of the sums. Now this is going to require an extra step. So here, I want square of the sums. Up here was sum of the squares, so I could have put a Q there. I'll leave it SOS. So SQOS equals 0, so I'm going to want to make that SQOS. I'm going to make that SQOS, but I got a little problem here. I don't want to square it anymore. I just want to add I. And then when I'm outside the loop, I want SQOS to be assigned SQOS squared. and then I'm going to print SQOS. Okay, so what's going to happen? I'm going to go through my loop, and I'm just going to add the numbers. 1, then 2, then 3, then 4, then 5, just like up here. And then at the end of the process, I'm going to square it. Now you notice I go out of my loop and come back here to the first column. Right? That's because I don't want to do this squaring inside the loop and do it every time during the loop. I want to do it outside when I'm done. And I have that variable. So if I do that, SQOS, then I think I'm going to get what I need. And you'll look here, 3205. That's correct. Okay? So now I've only got one thing left to do. Find the difference. And I'm just going to do it in the print line. Print the diff is, and I am just going to say SQOS minus SOS. And when I run that, I get 385, 325. The diff is 2640, which is 2640 right there, okay? So, right there, not a whole lot of code, but by using two loops and playing around a little with the variables, I've found my sum of the squares, I got my square of the sums, and now I found the difference, so I did what Euler wanted. But I've got one more thing that I have to do. Euler gave me a worked example for 10. I want to do it for the first 100 natural numbers. So how would I do that? This is the pregnant pause where you figure things out for yourself. You don't have to stop the video. I will pause for you. While I drink my coffee. Actually, while I pour my coffee down my beard. Piece of cake. There's only 2 spots, which makes me nuts, and we're going to fix it. But all I have to do is come here and make that 11 a 101 in both spots. Now I'm going to loop 100 times and not 10 times. And when I do that, I'm going to do the natural numbers from 1 to 100 for the sum of the squares. I'm going to do the same thing for the square of the sums. So now what happens? Now when I run it, I get 251, 64, 150. Is that the answer? I have no idea. I'm going to show you how we're going to check. First thing we're going to do, though, is that's going to give me, it's going to make my OCD fire off because I don't want to have to change that in a couple of different spots. So what I'm going to do is I'm going to create a variable here. I'm going to call that variable limit. And I'm going to make the limit at first equal to 10. And then what I'm going to do is here in my loop, I'm just going to use the variable limit. So now, all I have to do is change it in one spot. Now, if I run that code, is it going to work? Again, with these pregnant pauses are happening all over. The answer is no. Why? Because I've set it to 10. If 10 is the first thing I don't want, then this loop is only going to go 1 to 9, right? So when I run the thing, I'm going to get a funky answer that we haven't been getting, and that's kind of weird. What I want to do, and what a lot of people do in a Python context, is I could do 2 things. I could give it 11, but that kind of is weird because Python, the whole thing is readability. We want to go from 1 to 10. The variable should be 10. That makes a lot more sense. So what I'm going to do here is I'm going to fix up my loop by saying limit plus 1. And you see this in Python a lot. So now that it's limit plus 1, that 1 will be added, so it'll be 1 to 11. Now if I did it 1 to 100, it would be 101. So I'm always going to get that exclusive first thing you don't want at the end of the interval. So now if I rerun, now I'm back in business. I get my worked example with all of the things, the results that I have up here in my comments. But now if I just add the 1 0 and make it 100, now I'm back in business. Now I'm not going to do it, but I could also come in here and, whatchamacallit, make it an input statement, and then you could actually put in what you want the limit to be, and you can get something fresh every time. All right? But I'm not going to do that. There's another thing we could do, but I'm going to wait and probably do that later, because what you're going to learn is after Unit 3, we're going to deal with something called functions. We're going to come back, we're going to rewrite this program, and we're going to do it with functions. Okay? Then we're going to rewrite it again and make it even more efficient after that with libraries, and pretty much we're going to get to the point where we can do this entire thing in one line. And you must be, that may sound freaky right now, but yeah, we're going to be able to do this whole thing in one line. And when you'll see it, it'll be like, oh, okay, that's cool. We need to check our answer. We don't know if we're right or not. So I ran it for 100, and what did I get? I got 251, 6450. So let's highlight that, and let me go show you something pretty cool. let me go to sign in. And what I did, I don't want to go to Big Lars, is I created an account called PMDS capital S 2019. Okay, that's our class, spring of 19. And the password is lowercase python, uppercase CLASS, class. So you got an uppercase in there with the C, but that's it. And then I got to give this little code here so it knows I am not a bot. I'm not going to tell it to remember me, and I'm going to sign in. So now, sign in successful. You can see over here, you logged in as PMDS. If you want to log in under this ID and do some Euler problems and see if you can get the answers correct, be my guest. I think that would be cool. It's a good way to practice your new Python skills. And once you have simple data, if-then-else decision-making, sequences, and loops, then you're in really good shape. And you finally have enough tools in your tool chest that you can go out and start building programs that are actually solving real problems. Okay? Multiples of 3 and 5. Does that sound familiar? Maybe not 3 and 5. 3 and 7? Some square difference. Once I'm logged in as a regular user, there's a spot for the answer. So I'm going to punch in the answer. And then I have to give it a confirmation code so it knows I'm not a bot. And then I happen to know the answer is correct. So what you're going to get next is one of the neatest little buzzes in programming. You say check, and if you're correct, you get a check mark. A big green check mark. I've done this program for this class alone probably 10 or 12 different times. And I've done it with students over the year, so I know I'm getting the check mark. It's still a buzz. You still like getting that check mark. All right? That's what programming is all about, figuring things out. So, it's congratulations. What are we? That's not so bad. The 427,790th person to have solved the problem. And what you're going to learn now is that if I come up here and I go to progress, you can see your progress about all the different ones that you've answered. We only have the one. Okay? But you can go to different levels by doing 50 problems, 75 problems. We used to tell people, if you come over here to statistics, at the time, where are my problem stats? There we go. At the time, we would tell students to solve 50 problems. Because 50 problems made you a 5%er. Right now it's 5.37. So it's a little higher than it was back in the day. But if you solve 50 problems, that made you one of the top 5% people in the world. This is international, Project Euler, who was doing these number problems. Okay, it was pretty good stuff. Right now, you have to, it's pretty close, do 52. If you do 52, you are in the top 5%. And if you do, where's the cutoff for 1? If you do 110 problems, you are a 1%er. Okay? Not a Hell's Angel 1%er, but you're a math 1%er. You're a discrete mathematics 1%er. All right? And you can go to About and learn about Euler and learn about all the different things he did in mathematics. And you can always go back to the archives and look at all these different programs. And you can get the instructions for them and a whole bunch of different stuff. Okay? So that's Project Euler. Use it as a resource. It's a fun site. It's projecteuler.net. All right, now you have a login, PMDS-S2019, and the password is Python class. Make the C capital, okay? And as you can see, code's not hard, all right? I think I usually do, and I think I will drop this code in the file section. I have to drop some other code from the slides that I neglected to do that. Rob told me about that in an email a couple days ago. So I will drop some of that code in there. But the code you see in the slides, it's simple. You should just type it up, which is a good idea when you learn Python the hard way. You're going to see the ethos is type it in yourself, and then you'll make errors. And then to correct those errors, you have to know what the program is doing. So it's a great way to learn. Okay, correcting your typos if you type code from one source to another. All right, that said, you should be coming up with the code yourself, but you know what the deal is. All right? I am going to do some real quick announcements. Unit 2 is coming to an end. It is Friday the 15th. Tomorrow night, the 16th, the day before the end of the unit, at 8 o'clock at night, I will open up the quiz. As usual, you have 30 hours to work on the quiz. The assignments are due Sunday night. The unit ends on the 17th. So Sunday night at midnight, make sure to get me those 2 assignments. They're not hard, but when we have class, not next week, but the week after, we're going to go over these 2 problems, and you're going to see that they have historical significance in computer science, which may be hard to believe because they seem kind of easy, but you're going to see that they actually have special meaning, and I give them to you for a reason. Then Monday, Unit 3 is going to start. Word to the wise, okay? I had that little sentence in there in my slides that said, if you can tell me what \n does, then I will give you 1 point for extra credit. And a couple of people actually made mention of it. They said, why do you care? Why are you giving people 1 point? I could care less about the 1 point. It means nothing. I could care less about \n. When you ask for the extra credit point, it tells me when you're reading the slides. That's what it does, okay? And what it told me this particular semester is that you guys are waiting till the last minute to read the slides. You can't do that with Unit 3. Unit 3 will kick your ass up and down the street if you wait until the last 3 days. First unit, yeah, I get it. It was all about structure. You can see that earlier today I did the discussion post grades, all right? Piece of cake, want to make sure everybody learns Canvas, knows the system, knows how to post, blah, blah, blah. This unit, a little more challenging, but not crazy either, okay? It's grad school, loops, lists, strings, not, exactly going to stretch your brain too much, all right? So you're probably like, yeah, this is easy too. This course is going to be a piece of cake. Unit 3 is coming to kick your ass. Just saying. Just throwing it out there. So I did my little experiment with the \n, and I found out you're all reading the slides too late. All right? You're all procrastinating. Don't. When I open up Unit 3 on Monday, you want to take a day or two, walk around outside, smell the flowers. That's fine. Don't care. But you had better get on those slides quick. Okay? It's a 3-week unit. You're going to want all 3 weeks. I'm telling you. Read the slides. Get a hang of it. I'm going to get you videos rapidly. There's going to be 3 of them instead of the 2 that you're used to because it's a 3-week unit. And if you do it the right way and you engage right away, it's not going to be hard at all. It's going to be fine. You're going to be like, oh, okay, phew, this is great. The thing is, if you wait until there's only 3 days left, you're not going to get it done. You're not going to get it all done in time. And you're going to be crying, oh, can I have an extra day? Can I do this? The answer is no. You can't have an extra day. This is grad school. You're in the show. Okay? You got to plan ahead. You got to plan ahead, marshal your resources, and do the right thing. Okay? So at the end of this unit, and there'll be a couple of you, you send me that email saying, can I have an extra day to delegate my homework? My answer is going to be no. All right? Don't risk getting a 0. Don't risk screwing up your grade. If I had $1 for everybody who got a B because they were, arrogant about Unit 3, I'd be a wealthy man. All right? Just telling you. Just throwing that warning out there. All right? Crummy, arrogant professor talk over. I'm just at the end of this process, I do not want you to be able to say that you were not warned, because you were. You just officially got warned. All right, the last thing I'm going to bring up is that in a couple of days, probably over the weekend, do I want to do it to you on the day I give you the quiz? Yeah, I guess I could, because it's just an ask. I'm going to put out the information and the specs for the midterm, all right, which is a piece of cake. There's 3 online learning resources. Code Academy, Learn Python the Hard Way, and a Harvard CS50 video on Python. And what you're going to do is you're going to take a couple hours each and engage with those resources, and you're going to write me a compare and contrast paper. And then when you're done comparing and contrasting the 3 against each other, you're going to compare online resources with traditional brick and mortar classroom experiences. All right? That's a lot of stuff to talk about, and it's only 5 pages, which is 2.5 pages, and then the magic of double spacing makes it a 5-page paper. All right? So it's not a hard ask. Again, every time I run this class, I didn't know you're going to have to write a paper. Blah, blah, blah. You think it's just a programming class, and all you got to do is programs. No. This is grad school. It's about communication. Okay? You've got to be able to communicate technical things to a non-technical audience, both verbally and in written form, different forms of communication. So I always have people do a paper, and you would, oh my God, they cry, they cry, they cry, they cry, to no avail. It's because it's not hard. And at the end of the day, it gets fun. And I have to tell some people to stop writing. They're handing me 12 pages saying it's a draft and stuff. I'm like, whoa, whoa, easy. Editing, part of it is editing as well. Making sure to keep it short so you don't kill people. All right? All right. Then I think everybody in the class is doing great so far, by the way. This is a good class. Everybody's doing well. If Unit 1 is any indication, we're fine. Because everybody got it right away, got the assignments in there, did well, know what I'm talking about. You did your introduction, you did your quiz. For the most part, we're in really good shape. So frankly, I expect the same with Unit 2. Unit 2 is going to be like that too. Then Unit 3, 75% of you are going to heed my warning. You're going to do things in the proper sequence and everything's going to be okay. There's going to be 20% of you, they're going to play around, okay? Some people already know how to code. They just didn't admit it. So they're trying to get an easy A. I can't do anything about those people. All right? But then there's the people who are learning, and they're going to wait too long to get to Unit 3, and Unit 3 is going to do bad things to you. All right? Unit 3 is going to make you drink, drive you to drink. I'm just saying. All right? I don't want to scare you about it either. It's actually a fun unit. It's about modularizing your code and compartmentalizing it and using functions and using file I/O and using libraries. It's more about design. And when you're done with Unit 3, that's 7 weeks of learning the basics of Python. You're going to have the basics of an imperative programming language in your toolkit. And after that, we're using Python. You know Python already. Now we're going to use it. We're going to use it for CS. We're going to use it for learning about object-oriented programming. We're going to use it for data structures. We're going to do some data science finally. God forbid we do any data science in a data science class. So that's going to be it. I mean, in 3 more weeks, you're a Python programmer. Get ready. You can buy a t-shirt. You can get a mug. You can do all that fun stuff because you're going to be a Python programmer, whether you like it or not. All right? All right. And I've probably already gone on too long. I'm going to get out of here. You enjoy the weekend. You crank through the Python, and everybody's doing great, so you got no worries. Quiz is tomorrow night, and I will talk to everybody. Yeah, we'll all see each other in a couple of weeks when we have class. Remember, it's always the last Tuesday of the month when we have class over at Beck. All right? All right, good. Then I'll see everybody in a little bit. Bye.